Well, folks, Dan Abbott. I teach at Southern Maine Community College, and this is a welcome to the AEDD260 class, CAD Management. I just want to basically say hello, let you know a little bit about what the course is going to be about, and to give you sort of a sample lesson. So as far as what the course is going to be about, this is our syllabus, and this class is a upper level class. If you do not already know how to use Autocad, you're in the wrong place. And it's going to be relying fairly heavily on your knowing the software. I am going to start, though, with an exercise involving drawing speed. So we are going to sort of review some of the technical aspects of drawing with AutoCAD before we get started. But if you look at the syllabus, it's a fairly short list of objectives and topic outlines. So my goal here is, when we're done, to have you increase your drawing speed without sacrificing any precision or accuracy, of course. I'm going to create scripts for automation. I'm going to do a little sample lesson to show you what that means in a little bit. But a lot of what this course involves is automating processes so that you are more efficient and you do not have to go through as much tedious work as people often have to with the software. The course will focus on AutoCAD, but the concepts we're going to be covering would be applicable to any CAD program. We're using AutoCAD mostly because it's the most widely used CAD program in the world still, although not in any specific discipline. If you're looking at commercial architecture, for instance, you're more likely to find Revit being used for design. If you're looking at mechanical design for mechanical parts and machines, you're more likely to see SolidWorks being used. But Civil 3D is the most widely used civil program, and that is based on AutoCAD. Ship Constructor is becoming one of the most common design tools for designing large ships. Also sits on top of AutoCAD. And Autodesk has a number of other programs that are related, at least, to AutoCAD. The number of drawing files worldwide, probably close to 1 billion, I don't know, but it's massive. And that means it's a huge legacy group of DWG files out there. And almost everybody who uses CAD at some point encountered DWG files, and most people that I know of who are using software have to have something that they can use to open up and manipulate DWG files. So that's why we're using AutoCAD. Now, as far as what we're going to be doing here, a lot of it has to do, again, like I said, with automation, so that you can reduce the amount of tedium and increase your productivity. If you get on through here, we're going to look at the operating system. And operating system means disk operating system. And there's a lot of things that you can do at the operating system level, DOS, people call it, that people have overlooked because they're using Windows and they think this is sort of old school stuff. We're going to talk about some old school stuff in here because it's old school stuff that is really helpful in saving you time. At the end of this course, you're going to be taking 3 different kinds of files that are automation files and bringing them together. And one of them is a DOS batch file. The other is an AutoCAD script file, and the other is an AutoLisp file, which is a programming language that is built into AutoCAD. I have used a system that we're going to take a look at to update as many as 4,000 drawings with no user interaction at all. That's an enormous time saver. And I want you to leave here understanding that that is a possibility. And I also want you to leave here understanding that programming is not that scary, that people tend to think of it as scary. And we're going to ease ourselves into it by dealing with some of the easier programming concepts first, and then easing our way up into AutoLisp. You're going to create custom commands in AutoCAD. And those custom commands are going to be something sometimes as simple as new aliases and new external commands, and in some cases much more involved, using programming language that really does create some fairly sophisticated commands. Like, as I said, we're going to be dealing with the AutoLisp programming language. Lisp, LISP, list processing language is what it stands for. It's one of the 2 oldest programming languages still in use today, the other being Fortran. Fortran's a programming language that I first had to learn in 1968. It was a long time ago, so my experience with programming goes back a long way. I won't say that it's particularly deep these days in areas other than AutoLisp, but I do have a fair amount of experience with AutoLisp and some experience with Fortran. Those are the 2 oldest languages. The beauty of Lisp as a programming language is that there is a variant called AutoLisp that was designed specifically to work inside AutoCAD. And that means every AutoCAD command is available to you as a Lisp function. It means most AutoCAD users already know 70% or so of what they need to write very, very useful AutoCAD commands. It's important to us that everybody who could leave our program has some experience with programming. So this is the best way from our point of view to get you that experience. I'll show you how to customize menus in AutoCAD so that they're much more streamlined and give you better information. We'll take a look at the toolbars that you can create in AutoCAD. Tool palettes. Tool palettes are extremely useful. A very powerful tool that is often overlooked these days. And some accelerator keys. Accelerator keys are keys that you press to have things happen automatically. Then at the end, we're going to do a capstone where everybody has to create a series of programs that will update as many drawings as you want, as long as you can point to them, and as long as the updating involves doing exactly the same thing to every drawing. I'll give you some examples of what kinds of things that has been in the past. We're also going to take a look at database extraction from AutoCAD, as well as some stuff with external references that are a little more advanced kinds of things, and we'll take another look at templates and the use of attributes and blocks. So that's where we're headed. So just a sense of how we're going to do this. I am not going to have a scheduled Zoom class for you. This is an asynchronous class. Instead, I have created a survey, and I'm going to ask you to take that survey, which is located on our BrightSpace page. And I want you to take the survey because I'm asking you what times during the week would be helpful to you for me to have open labs. And what I'm going to do is schedule 1 or 2, maybe more, depending on the response I get, times when I'm available on an open Zoom call. You can just log in and ask a question or get some additional help. And that means you need to fill out that survey. It's a SurveyMonkey, and the link is on our BrightSpace homepage. So here is our BrightSpace homepage. The Open Lab Zoom survey is right here at the top announcement right now. There's a link right there. You pick that link. It'll take you directly to the survey. Oh, I've already taken it, so I can't do it again. You will not have already taken it, though, so you're not going to get this message. I've just identified times when I am available. That would be the most convenient for me, and that means Mondays and Fridays, and then even give you an option of telling me that the only time you have available is weekends. I'm hoping that's not true, but if it is, that's okay. We'll figure something out. All right, let's go look at AutoCAD. The first place, I've got this set up, and I'm going to do this throughout the class. I have my command line at the top. I've made the text larger. I've made the font a different size. And I've changed my color scheme, as you can see, so the backgrounds are sort of pale gray. And I'm using a dark background for my ribbon. I did that after surveying a couple of my classes to see what they found the easiest to look at online. And this was the color scheme that they thought was easiest to look at. Otherwise, this is just AutoCAD. I am going to be working from the command line because none of the commands can be called either in a script or in a Lisp program, except as commands. You can't go to a dialog box using either of those tools. So you're going to really have to make sure you understand the structure of the commands in AutoCAD and how they work at the command prompt. What I'm going to do is just give you a couple of examples of the kinds of things we're going to do. I'm going to start by running a script. And when I run the script, let me get over here, I use the term script. It comes up and it says, what script do you want to run? What I'm going to do is I'm going to go and find a script. And you're all going to have a Google Drive, by the way, and in that Google Drive is where I want you to store your material as well as uploading it on BrightSpace. We'll talk about that more later. So I'm going now to the faculty section of my Google Drive. I'm going to go to our folder. And I've got a folder in here called scripts where I've placed a number of scripts. And I'm just going to run the most impressive script that I've ever had a student create. And this script, I suppose before I need to do that nothing up my sleeve thing. So let me close this out and just make a point. We're in a brand new drawing here. I start this drawing. If I go into my layer manager, and by the way, I have my palettes all docked on the side so that they open automatically when I hover over them. There's a single layer in this drawing, and that layer is layer 0, as every drawing must have. So what does a script do for you? In this case, what it's going to do for me is to create some layers. So I'm going to go back and find it again. and I'm going to open it. It has to have an SCR extension. Happens to be the same extension that Windows assigns for their screensavers, which means you cannot send this to somebody as an email because screensavers are really little programs, and because they can contain malicious code, no email client will let you send one via an email. But AutoCAD uses SCR, and it has used them before before screensavers existed. So I'm going to run this thing right here by double clicking on it, and it comes in here, and I'm going to press enter, and I'm going to go over to the layer manager. And when I get to the layer manager, you'll notice that I have just created, by running that script, a lot of layers. Now those layers are the layers that are identified by the American Institute of Architects, and they can include, which is really the impressive thing that this student did, not only the layer names, but also sets colors for those layers. It sets line types for the layers when necessary, sets line weights for the layers when necessary, and then includes a description that comes directly from the AIA standard. This is an example of automation. Now I'm going to show you, this one might be a little bit daunting. I'm going to show you what it looks like, and then I'm going to show you how to write one yourself that is less daunting and I think will make a lot of sense. I'm going to open something called VList, which is a programming environment, and this is what that script that we just ran looks like. Now if you take a look up here, and this might require that I do something with the magnifier because it's a little hard to read and there's no way for me to make this any larger except for magnifying it. So if I come up here, the very first line of this script issues the layer command, and it issues the layer command with a negative in front of it, and that simply means run the layer command from the command line. Do not open a dialog box. There are a number of commands in AutoCAD that you can do this with a negative before the command name suppresses a dialog box, so you're not sitting there with a dialog box open and your script stops. And first thing it does is says, let's go make a layer. What's that layer going to be? Well, we're going to make a new layer. Then you go through a series of requests, and then the name of the layer, the color the color is assigned, the name of the layer is given for that color, line type, the line type continuous is assigned, the name is given as well, and then it has an enter at the end, and that enter goes back down to the next line, and the next line still has the layer as a command, but then goes through and it just repeats everything that it just did, but for specific layers here. So you can see there's a lot of layers that are assigned by the AIA. This is a fairly complex program only when it gets down to the description section, which is way down here. So here's the section that actually assigns descriptions to each one of the layers. Otherwise, it's a pretty simple program. It just repeats over and over again, but I think you'd agree that it would save you an awful lot of time. Let me now close out my magnifier, which I can do by finding, oh, here it is, it's over here. I've got two monitors, and every once in a while something shows up on the other monitor. So I'm going to now minimize this, and I'm going to go back now to a new drawing, which doesn't have any layers in it at all except layer 0, and I'm going to write a script using Notepad. I'm actually just going to type Notepad at the AutoCAD command prompt. Notepad is an external command in AutoCAD. You can create any external command you want. External simply means that it runs a program outside of AutoCAD while AutoCAD is still running. So if I press enter, it asks me for the name of the file, and I'm just going to call this, so that it's distinctive name, layers test.scr, because it has to have a SCR script. So it opens up, says it can't find it. Do you want to create it? I'm going to say yes. So now that's the name of our file. Now I'm going to start by just typing -layer. Now I'm going to do this a little differently than what you just saw, just because it's a little easier to understand. If you type something in AutoCAD, when you're done typing, you press the enter key. I'm going to press the enter key now. That would bring up the layer options at the command line. Now I'm going to say I want to make a new layer. Now what is that layer going to be? I'm going to put a space. The space is also like pressing the enter key. This new layer is going to be called, say, dim for dimensions. And now I'm done with the dim part of that. It's made the new layer. Now I'm going to say let's assign a color, C, space, which is like pressing the enter key, and let's assign the color blue to the layer I just created called dim. Now I'm going to press enter again, which now gets me to the next option, and then I'm going to press enter again, which would get me out of the layer command. And I'm just going to save this very simple script. And go to save as, and I will put it in my documents folder as layertest.scr. I'm going to leave it open. I'm going to come out here. First, what I'm going to do is type negative layer at the command line. This is not running a script. This is just showing you what the script is going to do. Type N for new, and it says what's the name of the new layer. I can list multiple layers, but I only gave the one, dim. You press enter, and now it gives you all the other options available for layers. I'm going to type C for color. Color I want to assign is blue, and I need the name of the layer to assign it to, which is dim. Then I'm going to type LT for line type. Continuous, I'm just going to press enter. I want continuous to be assigned to dim. And I think that's all I did before. So now I press enter twice, it comes out of the layer command. If I come over here and look at layer manager right now, I've simply just created a layer called dim that's blue that has a continuous line type. Now I'm going to start a brand new file. This brand new file has no layers other than layer 0 in it. And instead of typing what I just typed, I'm going to type the word script. I'm going to run that script that I just created. And that script I just created went into my documents folder. So I need to go up here to this PC, go to documents, and layers test right there. So that's the file I just created. I double click. You can see up in the command prompt that I have in the window, something happened. I come over here now. I've got a layer called blue. It's continuous. A layer called dim. It's blue and it's continuous. That's how simple a script file is. I think I'll just show you one other example of where we're headed. And you can see that's a very small, really easily created program, but you can also see how you could build on that. So you could write a script that completely sets up a drawing for you in the event that you open up an existing drawing, for instance, when nothing is set up properly and you want to go and fix that. A script can be extremely helpful in saving you a huge amount of time in doing just that. And, you know, as far as time savings go, imagine, if you would, what it would take to create all those layers with all that information. How long would that take you to do? In a script, you do it just once and you can run it anytime you want. I also want to show you some things about list programs. Some of you have probably already used some list programs in our classes. Let's do the one for stairs. So I'm going to go to units. I'm going to set my units for architectural. I'm going to set my limits so they're large enough so I can say maybe 40 feet by 30 feet. See if I got that in there right. No, I thought I had a typo in there. All right, now I'll do a zoom all so it goes out to the limits. Now I'm going to draw a line representing a floor. I'm going to offset that line 8 feet 3 inches. And I'm going to offset it up so that it represents the next floor. So it's just the difference between the two floors, and I want to put some stairs in there. I'm going to use a command called app load, application load. Some of you have seen this, I know, because I've demonstrated it to you. And those of you that haven't, I'm going to go onto our general folder, and nope, it's not in the general folder. It is in the student folder. Autolisp, yep, there it is. Autolisp. I'm going to find a program that I wrote called Stairs, and then I'll show you what it looks like. And again, this can start off being simple and you get more and more involved as you go. Stairs, we're going to be using the one called Lisp, which is right here. We're going to load it and close. Now I've just loaded a Lisp program, which is, I'll show you in a minute. It's just a bunch of, I'll show you right now, just a bunch of text. So if I open that up in VLisp, come over here, the same file that I just loaded, let me bring this over from my other monitor, that I just loaded, and we'll go back to student, Autolisp, and we're looking not for script files but for Lisp files. Lisp source, I just got the wrong thing. Stairs, Abbott right there. Open it up. This is what the program looks like. Now this again, might look a little daunting to you right now, but it's just like the script. There's things that I used over and over again, and you can see it's lengthy. Now, I'm not saying that it took me no time to write. It took quite a little time to write, but you'll notice all of it is simply text. And there's all kinds of places where you see things like a command name. So right down here, command P line, point 1, point 2, point 3, zoom extends. Those are all AutoCAD commands that you're familiar with. You can use all of those commands in a list program. Now, I've loaded the program called stairs, and it created a new command in AutoCAD called stairs. Gives me the option of doing 3-dimensional or 2-dimensional stairs. I've got a default, so I'm just going to press enter. Maximum riser height, let's just say I want 7 to be my maximum riser height, my desired tread width. Let's say I want that to be 10.5 inches, so I put 10.5. So I want the stairs to go all the way up to here, and I want the stairs to stop right here, start right here. It just goes through, creates a set of stairs, and it indicates to me what the total rise is, 8 foot 3 inches, and you knew that because I just told you that. The total run for that particular set of stairs is going to be 12 feet 3 inches. The riser height that comes closest to 7 inches for that particular total rise is 6 and 5/8 of an inch. The tread width is 10.5 because I told it to be 10.5. I'm going to have 15 risers and as a result 14 treads. And it's going to drop the stringer 3/4 of an inch, which just means right down here, in order to compensate for the floor, the finish system for the floor, the stringer, that bottom of the stringer had 3/4 of an inch cut off of it. Also got a kickboard right here. So what I've done now is I've got this thing set up, got a little nosing at the top, so it would go directly to the top of a set of, directly to the next floor. And each one of these is a closed P-line. So each one of these is something I can edit if I want after the fact. This is a closed P-line as well right here. And I did this by methodically going through, creating P-lines, joining them together, and using AutoCAD commands to do that. I think that's enough for right now. What do we have here? About 22 minutes. Idea here was to both say hello, welcome, give you a sense to see who I am, but also to give you a sense of where we're going with this class. Love teaching this class. You're going to be doing a lot of interesting things. A lot of it you're going to be on your own for, in the sense that I'm not going to give you specific assignments that there's a particular way to do. Instead, what I'm going to do is show you how to accomplish things and then give you a project that you need to use those tools for. Anyway, looking forward to it. I'm really anxious to see how the Zoom thing goes. Go ahead and make sure you fill out that survey and we'll get started.